semicircle with diameter AB minus area of semicircle with diameter DC. Minus area of semicircle with diameter CD. Area of square, you will have 10 square minus area of semicircle. Area of semicircle will be pi r square by 2. Okay, pi r square by 2, and radius of this semicircle and this semicircle will be same. Okay, it will be pi r square by 2 minus pi r square by 2. So it will become 10 square means 100. It will become pi r square by 2 minus pi r square by 2. It will become pi r square. Now what is the value of r? R will be 10 by 5, means 5 centimeter will be r. So it will be 100. Okay, so now I will keep this A2 plus A4 like this only right now. So A2 plus A4, I have this. Now in the same way, if from the area of the square I am removing the area of this semicircle, and if I am removing area of this semicircle, then what I will get? I will get this area. I will get this area A1 and A3. Okay, if from this square I am removing area of this semicircle and area of this semicircle, then I have A1 plus A3. So A1 plus A3 I can find. A1 plus A3 I can find area of square. Okay, area of square means 10 square minus area of two semicircles. Okay, that will be pi r square minus pi r square by 2 minus, I am writing directly. Okay, pi r square by 2. So it will become 100 minus pi r square, and r is 5 centimeter. Now we have A1 plus A2 plus A3 plus A4 we want to find. So we will add this equations. We have now this equation A1 plus A3 is equal to 100 minus pi r square. Suppose we have this first equation and we have second equation. So we will add first equation plus second equation. So what we will get? A1 plus A2 plus A3 plus A4. A1 plus A2 plus A3 plus A4, and we will add this and this. So it will become 200 minus 2 pi r square. 200 minus 2 pi r square. (200 minus 2 pi r square). So now we will find it. So we have this now. We have the value of A1 plus A2 plus A3 plus A4. Okay. Now what we want to find in actual area of the shaded region. Area of the shaded region. Area of the shaded region is equal to area of square ABCD. Area of square ABCD minus sum of the area of A1 plus A2 plus A3 plus A4. So we can find area of shaded region. Area of shaded region, we can find area of square minus A1 plus A2 plus A3 plus A4 will be 100. 200 minus 2 pi r square. Pi we can write 22 by 7, and r square. Okay, so we can write in terms of pi also. So it will be 2 pi. R square means 5 square. So it will be 100 minus, it will be 200. It will become 5 5s are 25, 2s are 50 pi. So it will be 50 into pi. Now it will become 100 minus 200 and minus minus plus 50 pi. Hmm. 50 pi. So it will become 50 pi minus 100. So it is given in the question, use pi is equal to 3.14. So we will not use pi is equal to 22/7. We will use this value because this is given in the question. If the value of the pi is given in the question, then we will use that value. So we will use this value. It will be 50 multiplied by 3.14 minus 100. So we can multiply 3.14 and 50. So it will be 0, 0, 0. It will be 5 for the 20, 5 1 the 5, 2, 7, 5 3 the 15. So it will be 0, 0, 7, 5, 1. 2 point, after 2 0 we have point, so it will be 157 minus 100. Finally we will get 57 centimeter square. Why the area is in centimeter square? Because sides are given in the centimeter. Okay, write down. This is a good question. You have to think in this question. Okay, don't draw this figure. Don't draw this figure, okay?
Sir, scroll down, please. Done, sir.
Okay, so now we have done enough in this chapter. We will start the next chapter, and I have covered the examples. Okay, and you should try the exercise also of this chapter. And if you have any doubt regarding any question in the exercise, then you can ask me. Only you have to do means for solving any type of question, you have to apply the basic concept that I told you. Okay, you have to apply the basic concept. Okay, then you can solve each and every question of exercise. Now we will start the next chapter, that is surface area and volume. We will start the next chapter, surface area and volume. Then when will be your final exams?
Sir, 24 February.
24 Feb. So we have to accordingly complete the syllabus on time. Okay. So next chapter is chapter number 13. That is chapter number 13. Surface area and volume. This is a lengthy chapter. Surface area and volume. So basically in this chapter we will find the surface area of different figures like cuboid, like cone, like cylinder. Okay, in 9th class you have done solid figures. In 9th class you have done solid figures. There you have seen what is the curved surface area, what is the total surface area. Again we will recall the 9th class. Again we will recall 9th class. And in this chapter one thing is removed. Exercise number 13.4 is removed with examples. Area of frustum is not there in your syllabus right now. Okay, so first we will take the solid figures. Okay, and we will see what is the total surface area, what is the curved surface area, and what is the volume of those figures. So first figure I am taking cuboid. First figure I am taking as cuboid. Okay, so cuboid is like this. This is cuboid. This is a 3D figure, cuboid. Suppose the length of the cuboid is L. Length of the cuboid is L. Suppose height of the cuboid is H. This height is H, small h. And suppose the width of the cuboid is this B. Okay, is B. Okay. Now for this cuboid, if you want to find the lateral surface area for this cuboid, if you want to find the lateral surface area, So in this cuboid, can you tell me how many faces will be there? Total number of faces in this cuboid? 1, 2, 3, 4, like this. This face, this face, this face.
Sir, 6.
6 faces. 6 faces will be there. So I am giving the name. Okay. So this will be this is the left face. This is the left face. This is the right face. This is the top. This is the top face, and this is the base face, or you can say bottom face. And this face is the front face, and this face is the back face. Now if you will find the lateral surface area, so in the lateral surface area you will have the I will represent lateral surface area with LSA, lateral surface area. So in the lateral surface area, if you want to find, then you have to find the area of left right face plus front and bottom face. Front and bottom face. You have to find that area. You will not include the area of the top face and the bottom face in lateral surface area. So you can find this area very easily. Area of the left face. This will be VH. This will be V into H. Area of the right face. It will be B into H. So it will be 2B into H. It will be 2 times of BH plus area of the front face. This is the front face. See. So what will be this area? LH. And area of the back face. Area of the back face will be also L into H. Okay, L into H. So 2 times of LH. You will get this area. BH plus LH. Okay, if you want to find the total surface area, total surface area So the meaning of the total surface area is the area to which you can paint or to which you can touch. So you can touch this face also, means all the faces you can touch, means whole of the area you can touch, or all the faces you can touch. So you will take area of all the faces, and when you will calculate area of all the faces, so there are 6 faces and two faces are identical faces. So you will write 2 times of LB plus BH plus LH. Okay, LB plus BH plus HL, or you can write LH, total surface area. Now if you want to find the volume of the cube, it will be length into breadth into height. Volume of the cube or cuboid. Volume of the cuboid. Now second thing is cube. Second thing is cube. So basically cube have all sides equal. Cube have all sides equal. So I am supposing the side of the cube as A. So all side of the cube will be A. So in case of the cube, if you will find the lateral surface area, so lateral surface area will be 4A square. Okay, lateral surface area will be 4A square. Okay, because in the lateral surface area you will consider left face, right face, front face and bottom face. So left face area will be A square, Left face area is, it will be a square, na? This area of this face will be a square area because all sides are equal. So there will be the area of 4 squares. That is why you are writing 4a square. Total surface area TSA. Total surface area is TSA. And volume I will represent with V. So total surface area, the cube have the 6 face and area of each face is a square. So it will be 6a square. Volume of the cube will be length into breadth into height. A into A into A cube. Okay, after that, there is one more figure, that is cone. That is right circular cone. Which cone? Right circular cone. So right circular cone is like this. Something like this, okay? This is a right. And why I am saying this is a right circular cone? Because the height of this cone will be perpendicular to the radius of the cone. Okay, means this angle will be 90 degree. Otherwise cone can be like this also. Like this also, okay? This can be also a cone. So we will study right circular cone. So this right circular cone has the height h. L is the slant height. What is L? L is known as the slant height. And radius of the cone is R. Radius of the base of the cone is R. So in case of the cone, the curved surface area of the cone. Okay, here what we have calculated, lateral surface area, because there are no curve. But in this case, we will say lateral surface area as curved surface area, means this area, except the area of the base. Okay, this area we will not include. This area will be the circular area. So we will remove pi r square, and other area will be the lateral surface area. Okay, this area will be known as the lateral surface area. So lateral surface area of the cone is equal to pi into r into L. Total surface area, you will, if you will include, then that will be what? That will be lateral surface area plus area of the base of the cone. That will be pi r L plus pi r square. Now volume of the cone is given by 1/3 pi r square into h. And in this case, this is a right circular cone. Right circular cone. What is the meaning of the right circular cone? Height of the cone must be perpendicular to the radius of the cone. Now next figure is cylinder. Right circular cylinder. Right circular cylinder. Something like this, okay? So this is a right circular cylinder having the height h and having the radius r. Having the radius r, okay? Right circular cylinder. Figure number 4. having the radius r. So for this, the curved surface area CSA, curved surface area is given by curved surface. If you will take curved surface area, then it means you will not take this area and this area of the base you will exclude, and the curved surface area of the cylinder is 2 pi rh. If you will consider total surface area, means you will consider curved surface area plus area of the base, okay, of the cylinder. So total surface area will be curved surface area, that is 2 pi rh, plus what will be this area, pi r square, and this will be pi r square. Pi r square plus pi r square, 2 pi r square. And volume of the cylinder is given by pi r square into pi r square into h. Write down.
Done, sir. Done.
You should learn all these areas, okay. And you should know what is the difference between the curved surface area and the total surface area.
Done, sir.
Okay. It will be 5th. Okay, Azaan, actually I am having a next class, so we will discuss rest of the things in next class. Okay.
Okay, sir.
Hello, Hiba.
Good evening, sir.
Good evening. So in the last class, we were discussing question number, this question we were discussing. So this is a ring. Okay, this is a ring, and this ring was initially at rest. Now this ring is moving down this plane. Okay, moving down this plane, and the surface of this plane is a smooth surface, and this height is a small h. Okay, and this ring have the mass m and the radius r, and it is given that omega of this ring is equal to v divided by r, and v is the velocity or speed of the center of mass. Now if this surface is a smooth surface, if this surface is a smooth surface, means there will be no friction, means there will be no friction, means there will be no external force. Okay, means there will be no external force, or we can say means there will be no external work done. Okay, there is no external force, so there will be no external work done. So we can apply here conservation of mechanical energy. Finally the ring will be here. Finally the ring will be here. Okay, so during this motion we can apply the conservation of mechanical energy. Conservation of mechanical energy we can apply. Conservation of mechanical energy.